So welcome to 2015 question A3. This is an intersecting planes question. So we've got graphic below shows a sculpture based on intersecting planes. The drawing shows the elevation and plan of our two intersecting planes ABC and ADE. Okay, so here we have our elevation plan and here we have our 3D graphic. Draw the plan and elevation of the line of intersection. Okay, so we need to find the line of intersection first of all and determine the dihedral angle between them. Okay, so looking at our 3D graphic, that will help us to determine the position there of the line of intersection, because we can see A is a point that's common to both of our planes. Okay, so A is going to be on our line of intersection. Okay, and as we look down here, we can see our line of intersection. Just highlight it. It's blue. Not quite that well, but we can see then that it intersects, or it finishes where the lines DE and CB intersect. Okay, so that is going to be a second point so that we can determine our line of intersection. Okay, so looking at my elevation, I can't really see where they intersect, but looking at the plan, I can see it. So here is A, which is a point on the line of intersection, and then where B, C, and DE intersect, that will be the position of the line of intersection. I'm actually just going to highlight that line. Okay, and then find that in elevation. I'll project that up vertically, and here's my line of intersection. Okay, so they're asking us then to determine the dihedral angle between the planes. So the dihedral angle will be found when after we find our line of intersection as a true length, and then we look along that true length. Okay, so if we look along the true length, we'll see it as a point view, and then that will allow us to see both planes as edges. Alright, so I am going to take an auxiliary view here, so looking perpendicular to this line of intersection. Just set that up. So my x1, y1. Okay, so project out all of my points, the line of intersection as well, forget about it, and D. Okay, so here's my x1, y1. Okay, I'm going to give just another name to this bottom point, or the other end of my line of intersection. I'll call that O. So O there. Right. So A is an auxiliary elevation. Right. We're projecting from plan to an auxiliary elevation, so my heights come from my elevation. Okay. So here I'll get the distance from A to my XY line. From A, that's my new A line. Alright, then all the other points we can see rests on the horizontal plane. So there's no height for them, well, its height is 0, so they're all going to be resting on the horizontal plane here. So A, E, AB, AO, which is the important line, AC, and AD. Okay, so looking in there, we're going to have our line intersection. Okay, and that is a true length line. Okay, so true length of the LOI, line of intersection. Alright, I'll just actually heavy in the edges, it should be heavy. Should see all of these, yeah, we will. Okay, so now I've got the true length of the line of intersection, so LOI, just label it there, LOI. We want to look along that true length so that we see it as a point view. Okay, so we want to see it as a point view over here. So perpendicular to my line of intersection. Let's set up my sliding set squares. Perpendicular to I'll project up all of these points then. Yo. Don't forget that point. Let's label these as well. E, B, O, C, and D. Okay, so we're projecting from an auxiliary plane, creating an auxiliary elevation, so we go back two views. Auxiliary elevation to auxiliary plane, so we go back two views to a plane. Right, so the distance from our x1, y1 back to that plane view. So get those distances. C, C up, E, B, D, B and D, and the distance from A to A, from x1, y1 to O and to A should be the same. So that we find it as a point view. So when I draw those up, it should all be crossing at point AO. Okay, so here is point A, comma O, and that is a point view of that. So we can say the angle here then, this is a dihedral angle. Just label it dihedral. Okay, so that is part A completed. Then determine the traces of plane ADE. So plane ADE here, we're trying to determine the traces of it. Okay, so ADE, right, A is obviously up there, D and E are resting on the ground, on the horizontal plane. Okay, so they're already part of the dihedral end, or sorry, they're already part of the trace, the HT. So if I extend on those, imagine this is my vertical plane. If I extend those on until they hit the X, Y line, okay, that is going to be the HT, and then I can find A off of that, or sorry, VT off of that. So DE, we're simply going to extend that on until we hit our XY line. So here's my traces. That's my HT. Okay. Then we want to imagine we're taking a horizontal section, a horizontal plane, intersecting that oblique plane. So that will create, I'll just actually highlight it here. So that's my line running. And then if I take a horizontal section through that plane, it will create a parallel line. Okay, so a parallel line to my HT from A. So let's say we go parallel to that. And that will be vertically up. This is similar to what was in question similar to what was in question A1 of this same paper. Okay, and that is my VT. VT. Okay, so exactly the same construction as we were looking at there in question A1. So that is 2015 question A3, a nice intersecting planes question, and a little bit of oblique planes thrown in part B.